Welcome to the Limitless Energy Podcast. We are here in Annapolis, Maryland for the Annapolis Boat Show. It is my pleasure to welcome to the podcast Conor Smith, the founder of Boat Doctor. Welcome.
Yes, thank you so much.
It's great to meet you.
Yeah, same here.
So Conor, Boat Doctor specializes specifically in lithium-ion battery retrofits on boats.
Yes, exactly.
How'd you get into that?
So I have to say, I was born and raised on a sailboat. I was technically
Where?
we did have a home. It was based in Chicago, but I was a August baby in Chicago, and my parents weren't going to miss the rest of the season just because I was born. So I was first on my parents' sailboat when I was 3 weeks old, and I guess I've kind of never left the boat. And I was later homeschooled aboard the sailboat with my brother and my parents. We traveled up through Canada, down the East Coast and the Caribbean, and we lived off-grid, off the battery system that we designed and engineered for that boat.
Really?
And back then it was wind generators and of course lead acid batteries.
How much lead acid battery do you
We had
do you remember?
6 of the golf cart batteries, so that is 660 amp hours, which half of that's usable. We had a wind generator, which made about 75 amp hours a day, and then we had alternator on the engine. And we were always out of power. And we were trying to do homeschooling. The only saving grace was that homeschooling for us was mostly paper and pencil. Now it's mostly computer-based. So the energy needs are we had a lot lower then. But it was really instrumental for me to be at such an influential age, at 10 and 11, being in the Fort Lauderdale Boat Show, going around to all the booths and vendors, just like at Annapolis here, looking at power systems with my dad, trying to make the decisions we were going to use for the boat. And then I lived with that system, trying to be homeschooled and all that for that time.
Is your dad an engineer?
No, he's a new home builder, but he was really hands-on, really mechanically inclined. So I grew up with him working on boats. I was in the engine room with him, changing oil and working on the engine and topping off the batteries with distilled water and the whole setup. So just really familiar and kind of stuck with it. And so I just have a fascination for off-grid systems, and especially when an off-grid system gets you somewhere you can't normally have power, right? If you go and you're in some remote place and you are living comfortably with the system that you designed and use and is functioning in a good way, it's awesome. It's a great feeling.
And then you went and did a PhD. You're Dr. Conor Smith now.
Yeah, technically Dr. Smith, yeah, but call me by my first name.
Okay.
Doctor.
You're gonna say Dr. Conor Smith.
No, in the sciences, right? It's really casual. Nobody really refers to that except in like an academic setting. But I just being on the water, growing up, checking the weather, the winds. Your whole safety and comfort relies on the wind and the waves. The knowledge of that is really kind of critical. So stuck with it, studied physics and meteorology in undergrad, and then went on to get a PhD, University of Miami, in marine physics, which is basically small-scale oceanography. So I studied how waves and currents interact and tried to better measure them from a radar that was mounted on a spacecraft.
A lot of fluid mechanics there.
A lot of fluid mechanics, yeah. Navier-Stokes, the a lot of different variables and equations, but those are an amazing experience. And the biggest thing that I miss from that whole experience is the other people, because when you find yourself in grad school, you don't accidentally, I shouldn't say you find yourself in grad school, when you go through the effort to apply through the whole application process, it weeds out everybody that's not interested in being there. So the community is like a hardworking, interested community, and the Rosenstiel School, so at part of University of Miami, the Marine Science Campus had marine biology, marine physics, geochemistry, meteorology. I'm probably missing something else, but everybody could universally go to and say, "Hey, how did you get into this?" And everybody had an answer, which was like, oh, I was on a beach and I saw this whale and I got stranded, or oh my gosh, I got caught in this hurricane, or tornado, or a weather phenomenon, and everybody had a story. So my story was growing up on the boat, and everybody had their own unique story. So it was a cool environment to be with that interested,
That's
hardworking
great.
group.
So did you start Boat Doctor like right after your PhD, or how long did that
No, I went a few years. I took off on a boat myself. I finished the degree, and during grad school, I was living aboard a sailboat and kind of slowly fixing it up during that time. And then so my treat to myself was a little hiatus on the boat with my partner, and we sailed down to Panama and back on that boat, and then sold the boat, moved to Florida, and I worked for a company doing some geophysical work and seafloor mapping, and then missed the marine electrical world and founded Boat Doctor. So to help
When
people.
was that?
So that was about a year and a half ago, and just kind of applying everything that I learned from living aboard the boats for 20 plus years with some of the, it's so hard, it's so much new technology. You really have to be totally in it to do the conversion safely and correctly. So I just saw the need to help people transition their boats, because a lot of these boats now are getting 20, 30, 40 years old. The boats are safe, the electrical systems are really aging, and they're trying to upgrade with lithium iron phosphate batteries, but they're not safely doing it. I kind of saw that need to kind of focus on that, provide that expertise to help people, convert their boats and get more power out of their systems.
And you're ABYC certified.
Yeah,
So
I just finished my third certification, so now I guess I'm the master technician. So it's been a fun ride.
So let's talk about ABYC and lithium, because
Sure.
I've been involved in that endeavor to figure out how to create metrics that form a compliance system.
Yeah.
How good a job do you feel ABYC is doing in terms of getting that information sorted out and getting it out there? And do you have any issues with it?
I obviously that the role there's a needed role, right? The implementation of good, strategies and suggestions and metrics to install systems that is needed. I think everybody's learning about how to implement this new lithium technology safely. The only, I guess, not to be put on the spot, but I mean, I wonder if some of this information is behind a paywall, and I think that is a little bit of a challenge to get the information to the people who need it most. And I think that's partially why I was kind of motivated to start a company that focused on this, because that information needs to get out there. And this podcast is great. I mean, there is so many, you guys are doing a great job getting that information out there, but that would be my only thing that I wish ABYC was a little more able to disseminate the information more rapidly and more available. But I think they're doing a good job developing the new the E13 standards, trying to get people to doing it safely. And I think I think overall they're doing the best job they can.
Yeah, no, I agree. It certainly is a collaboration. There's a lot of folks at the table, a lot of people involved. We're obviously a lithium-ion battery manufacturer, so there are issues that we see, and there are issues that we don't, not being specifically on boats. And so is there something unique, other than, there's obviously safety aspects, but is there something unique to being on the water from an electrical standpoint that you think is relevant for lithium-ion battery manufacturers to address?
I think, like compared to RV systems, off-grid systems,
Yes.
Yeah,
we've done a lot of those too. So.
Yeah, absolutely. Yeah. I think the biggest thing is in a marine environment, the importance of reliability takes precedence over everything else. It's in my opinion absolutely the most important thing, and I think it may not be the most important topic for other applications. Like the loss of power in certain instances on a boat, you could lose your life. I mean, not to be dramatic, but that's certainly possible. I mean, if you're navigating an inlet in the middle of the night and your radar and all of your navigation systems running on your batteries, loss of power in that moment, you could absolutely lose the boat. And then who knows what, how it's going to affect you. So that is just so critical to have absolute reliability. And that's why I'm really excited for these new batteries that are coming out that are able to communicate externally to give you notice, give you alarms and notifications. So if you are ever in these instances where the batteries, have if the charging systems have problems that are causing the batteries to go out of their safe working parameters, that you have notification to address whatever's going on to keep giving you power. So
yeah, no, that's absolutely right, and that was one of the most important comments that came up in the early discussions in the development of E13 was that there needs to be warnings because the battery.
Yes.
Yeah, you're right. In the RV, you lose power. All right, it's annoying.
Yeah.
You gotta pull over, or you gotta, or you're at least not in danger.
Yes. Yeah.
But yeah, so you need warnings. You have to know what's going on inside the battery. And as an electrician, as an installer of these systems, you kind of know what to look for. What do you tell your customers? Because they might even if there are warnings, do they understand what they're looking for if there's a low voltage alarm or if there's a potential high current alarm? So.
Yeah. It's so much of the work is so customized. Not only installation, but the training with each client, because you have to understand what their knowledge level is, and then you have to design a system that works not only to their boat and to their budget, but to their knowledge level, right? So we might install extra safety precautions if that boat owner is a more novice user.
Right. Some redundancy in the power.
Yes, absolutely.
In which case, it's not a matter of life and death anymore if they're,
Yes,
would you say
exactly.
in most cases that the lithium battery bank that you're installing is powering critical systems that could make it a matter of life and death?
Yeah, it depends. I've done it both ways, where the entire house bank is replaced with lithium iron phosphate, and I've also done kind of parallel systems where you have a critical loads battery that's being trickle charged from the house bank, which is kind of my preferred way. Just if everything goes wrong, you'll have a really natural warning, because like the cabin lights will go out, the fridge will go out, the stereo will stop working, but the boat's going to be sailing on the straight course, the running lights will be on, the GPS will be on. So you don't even need to have an alarm, just the boat is going to be operating differently.
Just a dumb lead acid battery there.
Yeah, just a dumb lead acid battery, right? But at least it gives you a step between. It's like, instead of having an alarm to tell you something's going on, it's just a completely redundant step that the boat will be behaving differently. That's unmistakable, right? Because an alarm goes off, you might go, "Oh, okay, what's going on? Why is there an alarm?" But like, the lights go off, the non-critical light, then you go, "Oh, okay, something's going on," and then you have time to rectify the situation, and it's a completely stressless, environment.
Right. I mean, redundancy obviously makes a ton of sense, especially in those conditions. But if you've got a separate battery, why would that battery be a lead acid battery, not another lithium battery? If they're less, I would consider lead acid batteries less reliable, especially if you're trickle charging them all the time and you're not using them, and then you never know when it's time to use them if they're going to be good or not.
That's true. Yeah, I guess in the environment where, in my experience, what kills the lead acid battery is the deep cycles, right? Like, I have personally killed a lead acid house bank in like 6 months. I mean, just because. And I think I'm relatively experienced with this stuff, and I've personally absolutely just destroyed a battery. I mean, I was like, I couldn't believe it. I was like, how am I getting low voltage alarms?
You knew you were overtraining them, didn't you?
I
thought they'd last longer.
I thought they would last longer. So in my experience, when they're trickle charged, in a quality AGM battery, they tend to be quite reliable. But it's true. If you are not regularly using it to know if it's actually working, that's true. Maybe that would be a good way to test that the battery is actually available for you when that charging source stops. But it could be another lithium battery. It's like, I guess the few at times, like, starting an engine, a lead acid battery seems to be work really well in that environment, right? It's simple, starts the engine, big rush, it gets topped off quick. It seems to work well. And so I've always kind of kept it simple, just using that as a interim step. But you could do other ways.
In terms of crank the engine, you're preaching the choir here, because the thing about lead acid battery or a lithium battery is that you never want to have a user have access to that power without some sort of protection in between. And that protection typically is, I think the safest protection is some sort of FET-based BMS, right?
Yeah.
In which case, cranking is really bad for that, right? That surge through a FET is just is not good. And so it actually, usually what we do is we have multiple chemistries, and you've got the cranking battery, driven by lead acid, but then you've got the critical loads and maybe some redundancy with lithium. So that's actually the way we like to do it.
Yeah.
So the reason I brought up the backup battery as a lithium or lead acid, it used to be convention to charge a lead acid bank from an alternator without anything else but a small lead acid battery, just to provide that capacitance to eliminate that flyback spike in the case that you get a BMS cutoff.
Yeah.
And what they were finding was that battery kept going bad.
Really?
That sacrificial battery kept going bad. So now we have the onset of more sophisticated alternator control, like the wake speed or DC-DC converters. Yeah. What has been the biggest pitfall for you in terms of alternator charging of a lithium bank?
I mean, it's heat management of the alternator. The lead acid batteries have such a high internal resistance, they quickly start pushing back and stop. The charging acceptance rate just falls down to tiny amounts, right? So when you're charging an alternator, it's a perfect break for the alternator to start cooling down and stop working so hard. Even on a huge battery bank, I mean, it's shocking how quick the ramp down happens, right? So, obviously, lithium iron phosphate, they take it almost all the way to the very end.
Until it's fully charged.
And that's amazing, but the alternator hates it. Yeah. I mean, it works really hard now. So that's the thing, knowing that, every installation includes provisions to keep the alternator cool. Blowers that come on a relay, not on a switch you throw on. When you turn the ignition on, they automatically come on. And that's something that I do automatically in any installation. So blowers come on, pull cool air out of the lower part of the bilge, blow it right across the face of the alternator, and then another one pulling the heat out of the engine room to keep that as cool as possible. Obviously, the wake speed has a alternator temperature sensor, which has to get put on and keep the alternator cool and working effectively. So I do that. I try to upgrade the wiring to it, so that way that's not causing any extra heat to the system. So just really trying to mitigate the heat to keep the alternator working. And then I always try to derate it, get a bigger alternator than needed, derate it by 20 or 30%. So it's just, working as as cool and easy as possible to get it working as long as possible, because I hate calls from past clients. I mean, I love hearing from them. I worry about a system breaking or not working. So I really want, reliability is really, really
You get a lot of those calls?
So far, they've all been basically social calls, and a lot of the clients are here at the boat show, and I'm calling me, and it's great social calls. But
each time the phone rings and it's one of them, your heart rate goes up.
And I'm like, oh, God, I hope everything's okay. Pick up, hey, I'm just checking in. I want this next thing now. Okay, great. All right, what a great conversation. But I really, I always try to make sure there's none of those calls.
So how many of you are there out there in terms of really specialized lithium installers, that are not ABYC certified?
Not many. There's not many, that's for sure. I'm in Northeast Florida. There's only a small handful that operate in the whole kind of the nook there, from Georgia down to like Cocoa Beach. I'm kind of the only one that specializes in it. But to be fair, I've gone all over. I have clients now in Michigan that I regularly fly up for. I'm putting a big generator replacement battery bank in a beautiful what's that? A trawler, a motor yacht. So I go all over for it now. Now once the word gets out, and find the right clients that kind of travel for wherever they are.
Well, we need more of you. I mean, there's a lot of lithium out there in marine, right? How much? What do you think the penetration is right now with lithium?
You know, I think those that are living aboard their boat, actively using it, it is certainly the majority now are switching lithium. I mean, 60-70% of people who are actively cruising their boat have switched to lithium iron phosphate probably, or are switching or thinking about it in the process of it. You know, I think the usage profile, if you're still a weekender, I don't know if the numbers work. It just doesn't make sense if you need a small amount of power infrequently. You know, the time it takes, the cost, it's just not really a priority for those, that usage profile. But but certainly those that are actively using the boat and going out and doing traveling, it's almost a must now. It's a life changer.
Cool. Well, before we wrap up here, can you tell me a little bit about your other activity in terms of bringing veterans sailing and training them?
Yeah. So like about 2.5-3 years ago, I started volunteering with Warrior Sailing. It's a nonprofit that helps ill and injured veterans. And we use the medium of sailing to help heal injuries. So they, a lot of non-visual injuries and illnesses like PTSD and depression, and just, the camaraderie and mission-focused activity of sailing is a great way to bring people together. And so when my role in the program is to teach the electrical systems of boating. They've learned to sail, they've come through our program, they're going on deliveries, they're going on friends' boats, they're buying their own boats. They don't know what's quote unquote under the hood of the boat they are on or sailing on or they're with. And we had a couple of stories of people that went out with a friend, they thought it was good, new boat, shouldn't be a problem, and all of a sudden all the lights went out and they had no idea how to help, how to fix, how to be of assistance. So we started a curriculum. It's a marine systems training with a focus on electrical, and I call it the basics of a multimeter. This is a multimeter. Here's the top 10 things you should check on a boat. Before you leave the dock, find the batteries, check the voltage, start the engine. You don't even have to know the exact voltages, just look for the voltage to go up. If you know that, okay, at least there's some basic charging that's happening. Unplug from the dock. Start the generator. Does it, flip on a charger? Does the voltage go up again? Just these basic checks of how, and here's an alternator. Here's, top couple things to look for and kind of these basic systems. So help keep our graduates, safer on the water, either on friends' boats or their own boats and stuff. So.
That's awesome. That's great. Well, thank you so much for the work that you do for the veterans, and really appreciate the work that you're doing for the industry as well.
Yeah, it's a pleasure. It's a lot of fun. It's a fun ride.
Thanks for coming on the podcast.
Yeah, thank you. Thank you so much.
Thanks for joining us on the Limitless Energy Podcast. Be sure to subscribe on any of your favorite podcast platforms.